practicing that muscle memory. So we've already actually seen the two-way tables a little bit in my example yesterday. We had that like non-defective and defective, and we had the like computers in the lab with CDs and new and used, those types of things. So we've kind of seen this before. Okay, so this is two-way tables and using them to calculate probability. So in those first blanks, you're going to write a two-way table. Displays the same information as a Venn diagram. So how many people remember Venn diagrams? Yeah, you've got one right below, right, in the notes. Okay, you can see it right down there. Okay. In the table, one of the categories is represented by rows, and the other is represented by columns. Okay, so we're going to say one is represented by rows, and the other represented by our columns. So I've got that image underneath of the Venn diagram there. Okay, and kind of like just look over all the information that's here. Okay. We're surveying 80 students. And so this big rectangle is all the sample space. It's all 80 students. Okay. And we're talking about students who play an instrument, students who speak a foreign language. There are some students in the middle there who do both. And then this little 9 on the outside, those are students who do neither. So let's see if you can take a minute with your pods, if you can fill in the blanks in that two-way table off to the side. What numbers go where? See if you can get an idea for that. I'd say the best advice is like tackle one at a time, right? And just see like, do I know it? Can I fill it in? How many people play an instrument and speak a foreign language in this top left box? 16. That's the overlap, right? How many people speak the foreign language but then don't play the instrument? That's the 30 over here that aren't included in the overlap, right? They only speak the foreign language. So that means the total over here is going to be 46. Okay. All right, how many people play an instrument but don't speak the foreign language? That's the 25 in the other circle there. And then how many people don't play the instrument and don't speak the language? 9. So that would give me a total of, what is that, 34? Now notice, if I add this last column down for the totals, 46 plus 34 is 80, which remember, that's the total number of students in this rectangle. So when you're making your table, everything should always work out. So now I know that whatever I get at the bottom of these columns, those numbers should also be adding to 80. So that's what? 41 and 39? Which sure enough adds to 80. Okay, so I've got all that information. Now go ahead and take some time to fill out the chart below. So read through and try to answer those questions and maybe check in with your groups, like do you agree or disagree? Okay, and I'll be walking around the room, so if you need me to clarify something, I will do that. So see what you can fill out in the questions in the chart below. Okay, I put on my first column answer, so if you and your Pi members want to just like take a peek and make sure we agree on the first column there, then you can maybe go over and talk about that second column where we start asking about probabilities. Think about when you're doing the probabilities, you're thinking about favorable over total. And I'll give another hint for that second column. Make sure you read the question very carefully to determine your total number of students. Well, for probability, we want to do favorable over total. So what's the probability that a student plays an instrument? 41 out of 80. What's the probability that they speak the foreign language? 46 out of 80. What's the probability that they play the instrument and speak the foreign language? 16 out of 80. What's the probability that they do neither? Will be 9 out of 80. And then what's the probability that a student plays an instrument and does not speak a foreign language? 25 out of 80.
For these, do you want to simplify the fraction?
Yeah. So like just like normal, if it was your final answer, you'd simplify the fractions, or you can write them as decimals, whichever you prefer. Yep. So all of those, when you were reading what's the probability, it just said like what's the probability in this scenario that the student that has this characteristic. That means you weren't given any special information about the student, so you're going to take it out of the total students possible, which is 80. Which I think is like our go-to option, but remember you have to be careful, like that question about the customer who bought gasoline also bought a drink, then that gasoline would be a given for us. Okay, and I'm just going to put in my notes here reduce, but I'm kind of running out of space there, so I'll leave them be. Okay. Now we got, I think next we got a whole bunch of vocabulary to take care of. Is that true?
Yes.
Okay. Okay. A two-way table is something called a frequency table. Okay, and when we say a frequency table, okay, I'm just talking about like frequency is like a tally of how many times something happens. So it's just like counting up the number of ways that certain things happen. So like in that example, let's tally up the number of students who speak the foreign language. Let's tally up the number of students who play an instrument but don't speak a foreign language. Okay, so that's what I mean by frequency table. That displays data from one source that belongs to two different categories. Joint frequency is every entry in the table. Okay, every entry in the table. So I'm actually going to flip back to my previous slide here so I can point out, I'm going to like highlight where my joint frequencies are. What does joint mean? Like together. So when I'm talking about every entry of the table, I'm talking about in the table here, where like here's my two different categories. The instrument is a category, and you can either play the instrument or not play the instrument. My other category is the foreign language. So I either speak the foreign language or I don't speak the foreign language. And the joint frequencies are all of the entries where we're putting those things together. Whether it's I play the instrument and speak the language, I play the instrument and don't speak the language, and the others as well. Okay, so that's what I'm talking about when I say joint, is those two things together. Okay, so these things right here, these are your joint frequencies. Okay. Marginal frequencies are the sum of your rows and your columns. Okay, so marginal frequencies are the sums of the rows and columns. And think about the word marginal. What does marginal mean? On the margins, on the outside, right? So when you're looking at your table, if you're ever asked about marginal frequencies, oops, I went the wrong way. If you're ever asked about marginal frequencies, you're looking on the outsides of the table where the totals are. So those are our marginals. Understanding the difference between where the joints happen and where the marginals happen can just kind of help you in case a set of directions asks specifically about one area of the table, then you know where to look. Okay, so vocab can be really helpful in this section. Okay, now we've got a joint relative frequency and a marginal relative frequency. Okay, so let me just ask you, what's the only difference in these vocab words from the two previous vocab words? The word relative. And so when we add in the word relative to both of these definitions, to be relative, you have to be related to something else. Okay? And a relation in math is represented by a ratio. So we're comparing two values. So a joint relative frequency, we're going to say, is the ratio of a frequency that is not in the total row or column. So remember, it's a joint. Relative frequency, so it's got to be where they're together. Okay, so they're not on the margins, they're not on the outsides, they're not in the totals of the rows and columns, they're in the middle of that table. Okay, to the total number of values or observations. So when you think about that, it's a ratio of some of those numbers on the inside of the table to the total values or observations. That's basically calculating a probability. So I'm just going to put in parentheses out here. Essentially what you're doing is calculating a probability. The marginal relative frequency then is obviously going to be those things that are in the margins. Okay, the ratio related to the values in the margins to the total values. So I'm going to say the sum of the joint relative frequencies in a row or column. Okay. Now the last one, talked about yesterday, conditional probabilities. We're talking about conditional relative frequency. Okay. So again, it's got that same word relative, so it's a ratio. It's going to be a relation, yep, of two values, so it's going to be a ratio. It's a ratio of a joint relative frequency to the marginal relative frequency. So the big difference there is if it's conditional, it's not for the full total, like not for all 80 students. It's only going to be related to the one margin that you care about. So it's like you have a given. Okay, so like maybe you know the student plays an instrument, then you want to know what's the probability that they speak the foreign language. Okay, so you're looking only at the column for the instrument. Okay. It gets a little bit like heavy with all the words. So, you know, go back and look at this, but again, also think about how we're highlighting areas of our table so that you know where the joints are and where the marginals are. Okay, let's do our first example. You randomly survey students about whether they are in favor of planting a community garden at school. Of the 96 boys surveyed, 61 are in favor, and of the 88 girls surveyed, 17 are against. Organize the results into a two-way table. Find and interpret the marginal frequencies. So first of all, I'm going to focus on my table here. Now, remember in the two-way table, what's included in a two-way table? Rows and columns, and it represents well, what do you have for a two-way table there? What's important information in a two-way table? Two different categories. So always before you start building a two-way table, you got to decide what your two categories are. And I'll be real honest, like on quizzes and tests, that is sometimes the hardest part for my students because I can't decide what the two categories are, and so then you can't make the two-way table if you don't know what specifically your rows and your columns are going to be. So what do you think we can make rows or columns for this particular example? Kaylee?
Rows for boys and girls.
Okay.
Columns for for and against.
Okay, so we have two categories. We're grouping the students by gender, but then we're also grouping students by how they responded to the question. So yeah, I would think about one of those is going to be gender and the other is going to be voting, I suppose. So we'll say for, we'll say against. Make a little table. Okay. So now we can fill it in. Go ahead and fill in the numbers. So notice on this one, you'll use the total number of boys and girls, the 96 and the 88. Those would be marginal frequencies, like a tally up of the total number of boys and the total number of girls. So these are out here in the margins. But you'll need that information, like if 96 boys are surveyed and 61 are for, then obviously 35 are against. And you may at the same time just kind of want to fill in your other marginal frequencies in case you need them later. So if you want, you can just add down. That would be what? 132 and 52. And remember, both of those, like those total rows and columns, they should add to the same number, which would be the total number of people who were surveyed. Is that 184? Okay, yeah, they both add to 184, so we're good. Okay, so there's my two-way table. How much of the like boxes and rows you do is kind of up to you. I usually just do 4 and then do around the sides if I need to. Okay. Now, it says find and interpret the marginal frequencies. So we've already found the marginal frequencies. Where are the marginal frequencies? On the what? On the sides, okay, in the totals. So I'm going to underline in red here marginal frequencies, and then I'm going to box my marginal frequencies. So what we're doing here is trying to like take data and like assign data specific names, okay? So when it says find and interpret the marginal frequencies, you could say something like this. 96 boys and 88 girls were surveyed. So that's me interpreting the marginal frequencies on the right side of my table. Okay, 96 represents total boys, 88 represents total girls. What do the marginal frequencies at the bottom of my table represent? The votes. Okay, so of the 96 boys and 88 girls that were surveyed, 132 students were for the garden, and 52 were against. So you may be asked on your homework to do something like that where you interpret it. So you just write a quick statement about what you're seeing. What do those numbers actually mean? Okay, put it in your own words. But it should be very clear and very like succinct. Okay, it doesn't have to be a long description. Okay. Next example. Complete the two-way table, and then we're going to use the two-way table to create a table that shows joint and marginal frequencies. Sorry, I meant relative frequencies there. Do I have that in your? I don't have that, but I'll change it in a minute. Okay, see if you can complete the table based on the information that's given. So I filled in on my totals there first because I know they have to add up to 130. And then I know this one value, people who walk were tardy, there were 22 of them. But now the people who walk there have to be a total of 70, so that's got to be what, 48? And then the on-time people, there's 48 from the walking, the city bus adds to 58, so there must be 10. And then, of course, this means this must be 50. Either add down to get 72 or add across to get 60. For the next part of this, we want to add in here the joint and marginal relative. I'm sorry, I forgot relative. Okay, you should say relative frequencies. Okay, so remember, if you're asked about relative means what? Ratio. It's a relation of two quantities. It's going to be a ratio of two quantities. So what we're going to do is we're going to take all the values here. Okay, for the joint, those would be the 4 on the inside. For the marginal, those will be the ones on the outsides. And we're going to divide them by the total number of people, which is 130. Okay, so I'll just show like a little bit of work. I would do 222. Sometimes I step on it. 22 divided by 130. And then I'm just going to do them as decimals. So I'll show my work for this. For this one. 22 over 130, that's 0.17. And then I'm going to do the others without writing them out because it's going to get too squished. So this is 0.37. 50 divided by 130 is 0.38. Now, all the properties of the table should still hold when you do the relative frequencies if you divide every entry by 130. So like 0.17 plus 0.37 should add to make this total marginal frequency 0.54, which it does. Same for your columns. 0.37 plus 0.08 should add to make 0.45. It does. And then what do you notice both of these add to make? 1, which is 130 divided by 130. So this one should always be 1, okay, if you evaluate it, but not really necessary. Okay. So that's showing relative frequencies. Remember, think about relative frequencies as a relation or a ratio, which basically represents a probability. So I like to write them as decimals. Okay. All right, last example. I'll give you some time to read. And then actually I'll probably give you, I'll give you and your pod members some time to read. Read the scenario, read the questions, and see if you can come up with some answers to probability. And we'll compare in a little bit here. Okay, I liked it as I'm walking around. I saw some people go straight to calculating their marginal relative frequencies. That'd be totally fine. You're just going to add your columns, add your rows. And then you have them if you need them. You can go at it one of two ways. Only get them if you need them or get them right away. Okay, either one works. You'll have to be really careful when you're reading these problems. What's the probability that a randomly selected parent voted to eliminate the class? You have to look only at the parents because that's your given. So if I'm writing that out in probability notation, it's the probability that they voted, is yes and eliminate? Or, okay, that they voted yes, given that they were a parent. Okay. And that kind of takes us back to that question that we asked on our homework. If you want the conditional probability, you got to take the probability of both of those things happening and divide it by the probability of A. So here our probability of A would be the probability that it's a parent, and we want our marginal frequency for parents. Okay, so we would take 0.58 divided by 0.64. Did anybody get that as a decimal for me? 0.906. I'm going to put 0.91. Okay. So 91% of the parents voted. If you randomly select a parent, they voted yes. Okay. What is the probability that a randomly selected student did not want to eliminate the class? So now we're looking only at the column for students. Okay, so we're going to focus on our students over here. That's the probability that we said no, given that we were a student. And that would be what? 0.15 over 0.23? And what did you guys get for that? 0.65? Okay, 0.65. Okay, so there seems to be some discrepancy there between parents and students. Now, the last question says, determine whether voting to eliminate the class and being a teacher are independent events.
Yes.
How are you arguing that?
Just because you're a teacher doesn't mean you're the same as.
But what if it did?
There are teachers that say so.
What's the difference between independent and dependent events in terms of their formulas from yesterday?
Like the probability of A times the probability of B.
Mm-hmm.
For dependent, it's the probability of A times the probability of B.
Yep. Okay, so the big difference between independent and dependent events is this second probability, right? So remember, if they're dependent, the second probability changes. So if we want to know whether voting to eliminate the class and being a teacher are independent, then we want to see, is the probability of voting yes the same as the probability of voting yes given that you're a teacher? If those two probabilities are the same, then it doesn't matter if you're a teacher. Because B given A is the same as B, which means A has no effect on B. So you could then calculate to see if those two are the same, and I think we would argue in this case it is a no. Okay, so So they don't, no, they're not independent events. They are dependent. The teachers, for whatever reason, that the teachers may have, they have a reason to vote. It's dependent on something. Okay, so it would be not, they would be not independent, or they would be dependent. Okay. You have a homework assignment, and you also need the quiz review. So I don't think the homework will be too terribly long here.
You get some lunch every day.
So remember, your quiz is happening on Monday. I will post the answer key to the review online, and I think I'll probably also post an answer key to the assignment, just so that as you're doing it, you can make sure that you're doing it correctly. So I'll have both of those things posted online, and you can use them to prepare over the weekend. But Monday, we'll be taking the quiz in class. So we don't have a review day. We're going to nix that because of the snow day. And we're going to quiz on Monday. So be ready.